Hi, this is Alex from devstories.eu. High Performance Python Async, Episode 9 of 17. Opening a new database connection for every incoming web request is a highly effective way to completely crash your server. The network overhead alone will stall your application, and you will quickly exhaust the connection limit on your database. The solution to this is connection pooling. When you use a library like asyncpg to talk to PostgreSQL, establishing a bare connection is an expensive operation. It requires a TCP handshake, secure negotiation, and database authentication. If you run a high-traffic web service, you simply cannot afford to pay this latency tax on every single HTTP request. Instead, you need to maintain a steady collection of ready-to-use connections. In asyncpg, you achieve this using the create_pool function. Typically, you call this function once during your application startup phase. You provide your database credentials, host, and port, and asyncpg spins up a set of idle connections in the background. From that point on, your route handlers and background tasks never create a new connection from scratch. They only borrow existing ones. There is a common trap here that trips up a lot of developers. Do not confuse borrowing a connection with opening a database transaction. They are entirely separate operations. When you borrow a connection from the pool, you are only reserving the network socket for your exclusive temporary use. If your operation requires atomicity across multiple queries, you still have to explicitly start a transaction on that specific borrowed connection. Think about a high-traffic fast API or AIO HTTP web service. Let us say you have an endpoint that accepts an integer, queries the database to calculate the power of 2 for that number, and returns the result. When a request hits your endpoint, you call the acquire method on your pool object. You do this using an asynchronous context manager. This temporarily checks out one connection from the pool. You then use that specific connection instance to execute your database query to calculate the power of 2. Once the code block finishes, the context manager automatically releases the connection. It wipes its state clean and hands it back to the pool, making it immediately available for the next incoming HTTP request. If a sudden spike in traffic hits your web server and all the connections in the pool are currently checked out, the next request does not crash. It waits. The acquire call will simply pause execution until another request finishes and returns its connection. Here is the key insight. The connection pool does not just save time on network handshakes, it acts as a strict, reliable concurrency throttle. It protects your PostgreSQL database from being overwhelmed by an unexpected flood of traffic. If you configure your pool to hold exactly 20 connections, the database will never see more than 20 concurrent active queries from that application instance, no matter how many thousands of simultaneous requests hit your web server. Thanks for tuning in. Until next time.